MACHHOLZ, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 63 for the week of March 17th, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, March 17th, the moon is a thin crescent in the evening sky. It will reach first quarter on Sunday, March 21st. All this week, the moon will be growing in brightness each evening. By next Tuesday, the moon will be 75% illuminated and in the evening sky for most of the night. On Friday, March 19th, the moon passes 3 degrees south of the planet Mars. Each podcast has handouts, which you can download from my website. This week, Podcast 63, Map 1, shows the evening sky, while Podcast 63, Map 2, shows the morning sky. The sun crosses the equator headed north on Saturday, March 20th. With the sun on the equator, everyone gets 12 hours of sun that day. The sun will rise due east on the morning of March 20th and set due west that evening. For the next 6 months, the sun will be north of the equator, warming the northern hemisphere more than it warms the southern hemisphere. Let's talk about twilight. The numbers to remember are 6, 12, 18, and maybe even one more number I'll discuss later. That is how many degrees the sun is below the horizon at each twilight. Let's assume that the sun is setting at 6 p.m. tonight. After sunset, there is still some light in the sky. The sun continues to shine on the upper atmosphere, and that illuminates the sky. As the sun sinks more and more below the horizon, the sky gets darker until finally it will get no darker. Well, actually, it does continue to get darker as zodiacal light retreats to the horizon and as fewer atoms in our upper atmosphere recombine and give off a faint amount of light. But at a certain point, the sun is no longer interfering with our night sky, and we can do some serious astronomy. Note, too, that the sky does not darken uniformly. The last areas to darken are near where the sun set. I once did an experiment. I seldom photograph the sky, but I did from Loma Prieta, California, in early August in the early 1980s. After finishing a comet hunting session, I put away the telescope and took out my camera and tripod. I then photographed the rising of the constellation Gemini with the stars Castor and Pollux, taking a photo every few minutes. This gave me a profile of the way twilight affected the sky, brightening the areas near the upcoming sunrise point first, with dimmer light spread out and up from that point. Much higher in the sky stayed dark longer, while the eastern horizon is getting brighter. That might seem obvious, but I suggest you examine that too. You will see that when the atmosphere is dusty, hazy, or humid, twilight is more scattered. There are 3 defined states of twilight, and it's a good thing to learn about them because they are sometimes used in astronomy. From sunset until the time the sun is 6 degrees below the horizon is called civil twilight. Does that mean people act civil to each other during that time? Unfortunately not. But you can continue to play baseball and walk on the beach and fly a drone without turning on the lights. Civil twilight can last as little as 24 minutes after sunset, which occurs at the equator, to even, several days long, as it does at the North or South Pole during certain parts of the year. Those are the extremes. But typically, those of us at mid-northern and mid-southern latitudes, civil twilight lasts about 30 minutes. In the winter, civil twilight is shorter than it is in the summer. Now, the opposite is true in the southern hemisphere. Their June civil twilight lasts shorter than their December civil twilights. The time between when the sun is 6 and 12 degrees below the horizon is called nautical twilight. This is when the baseball game ends. During this time, you turn on both indoor and outdoor lights. It becomes more like night than day. Some of the bright planets and stars begin to be visible in the sky. The third stage of twilight, called astronomical twilight, is when the sun is between 12 and 18 degrees below the horizon. In practice, it is dark enough to do some serious observing when the sky is 18 degrees or more below the horizon. How long does it take from the time the sun sets until the end of astronomical twilight? Well, it depends. It depends upon your latitude in the sun's declination, which is related to the time of year. So it is your latitude and the time of the year. In the summer, June 23rd, when the sun is furthest north, the sun is above the horizon for anyone north of what is known as the Arctic Circle, about 66.5 degrees north latitude. Anyone living north of 48.5 degrees latitude will not have astronomical twilight, and north of 48.5 degrees, that can last for several weeks or months. On the flip side, in winter, late December, there can be some very long nights in the northern polar regions. When I lived in Northern California, we did public star parties. Some were near town and some were up in the mountains. Summer had the warmest weather and the best chance for clear skies, so we scheduled one or even two per month during the summer up in the mountains. They would typically last 90 minutes. Some of our best were at a place called Big Bend, California, at 5,800 feet elevation along Interstate 80 in the Sierras. The question is, what time do we start a 90-minute star party in the summer? Start it too late, and if it concludes at, say, 11:30, we have people driving home to Sacramento, which is 90 minutes away, or Auburn, which is 60 minutes away, which puts them at greater risk of falling asleep while driving or running into someone else who is falling asleep while driving. Plus, we found that the kids tend to get sleepy early in the night. On the other hand, if we started too early, then the stars would not even be out at the start of the star party. Our solution was to start the star party at 9 p.m. Then it would end by 10:30, and everyone would be home by midnight. But at 9 p.m., the sun was only 6 degrees below the horizon. Therefore, I would give a 10-minute talk to the guest at 9, and that would allow some time for the first stars to appear. Also helping us out was that our first targets were bright stars and planets, if any planets were available. By the time we had shown the bright stars, the fainter double stars took their place. As the night progressed and the sky darkened even more, we showed more of the Milky Way items. Astronomical twilight did not occur until about 10 p.m., with the star party nearing its end. And we saved some of the best extended objects for that final half hour. The star cloud M24 would often be my last object of the night. People were adapted to the dark, the sky was dark, and it showed very well. Twilight times reverse in the morning, with astronomical twilight occurring first, followed by nautical twilight, followed by civil twilight, then sunrise. You can find the time of twilights for your location by using an app. Several astronomy apps are available which give you sunrise, moonrise, and times of twilight. 25 years ago, I looked over my starting and stopping times for comet hunting and compared those times with the times of sunrise and sunset. Now, comets tend to be discovered near the sun, the first place to set in the evening and the last place to rise in the morning. Additionally, twilight is strongest in the areas near the sun. If I waited until astronomical twilight ended to start in the evening, or stopped in the mornings at astronomical twilight, then I would miss some of the areas near the sun. But if I started too early in the evening while it was still rather light, or prolonged too long in the morning until the sky was getting bright, then there is very little contrast and comets can be missed. I discovered that consistently, the sun was a certain number of degrees below the horizon when I started or stopped comet hunting. It wasn't astronomical twilight with the sun at minus 18 degrees, and it wasn't nautical twilight with the sun at minus 12 degrees. It was between those two times when the sun was at minus 15 degrees. When a program called Moonrise was written by the late Bruce Seidel, a program that showed moonrise and moonset times, sunrise and sunset times, and the times of twilight, I wrote him and asked if he could customize a program for me that gave the times for when the sun would hit 15 degrees below the horizon. He did, and he called it Comet Twilight. So there you have it, Comet Twilight Time, sun minus 15 degrees. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, March 17th through Tuesday, March 23rd? It all depends upon your location. This week we have 6 zones. All you need to know is your latitude. At 65 degrees north and north of that, and at 50 degrees south and south of that, you will not be able to see the International Space Station at all this week. From 50 to 60 degrees north, the ISS will be in your evening sky sometimes twice per night. But you won't be able to see it until beginning later in the week. From 32 to 50 degrees north, the International Space Station will be in your evening sky, sometimes twice per night. Now is your week to go see it, latitude 32 through 50 degrees north. From 12 to 32 degrees north, you'll see it in your evening sky, but only for the first few days of this week. From 44 degrees south to 12 degrees north, much of the world, the International Space Station is in your morning sky, but not for the whole week, only for a few days this week, morning sky. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. There are no bright comets in our sky this week. Our telescopic challenge this week is let's try for a couple bright double stars. The first is Rigel and the second is Sirius. Rigel is easier to split than is the star Sirius, so we'll start with Rigel first. Rigel is in the constellation Orion. It is marked on podcast 63, map 1. It has multiple stars, but we're only going for the two brightest. Rigel A, the brightest star, is 800 light years away, much larger than our sun and many times more luminous. It varies very slightly in brightness from plus 0.05 to 0.18. Rigel B is magnitude 6.7, which is 400 times fainter than Rigel, and it's 9.5 arc seconds to the south. With a steady night, a medium to large telescope should be able to split this pair. I've been able to do it several times. Crank up the magnification and see what you can see. Now the star Sirius, the brightest star in the sky, is also a double star. It is identified on podcast 63, map 1. Here, the brightness or magnitude difference is large. Sirius shines at minus 1.46 magnitude, while its companion, known as Sirius B, is magnitude 8.5, a difference of 10 magnitudes. The fainter star is northeast of the brighter star. They will be 10 arc seconds apart for the next few years on their 50-year orbit. Now for fun with the marathon. I did a Messe marathon from my ranch in Arizona on Saturday, March 13th, Sunday, March 14th. A Messe marathon is an attempt to see all 110 galaxies, clusters, and nebula, cataloged by Charles Messier some 250 years ago. It snowed that morning of the 13th and again in the afternoon for a while, but the snow melted and the sky cleared by evening. I set up my 16-inch, 0.41 meter reflector telescope on a Dobsonian mount. This is only the second time I've used a telescope this large for the Messe Marathon. In the evening, I picked up the first 66 objects in about 90 minutes. That was all that there was above the horizon. I then went into the house to do some work, then to bed, then up again at 3:45. The temperature was below freezing, but there was very little wind. I picked up the remaining objects in the next 90 minutes, missing only M30, which is too close to the sun at this time to be observed. I used my star atlas to find a couple of objects. All the rest were found by memory. The Dobsonian mount is a bit sticky in the alt-azimuth movement, and that made it difficult for objects high in the sky. This was my 63rd Messe Marathon that I have started. I've completed 49 of them, the remaining 14 having been clouded out in the second half, that is the morning sky. To recap the podcast, what is up this coming week? The moon will be bright in the evening sky. The sun moves north and crosses the equator. And see the stars Rigel and Sirius. See if you can split them. You have been listening to Looking Up with Don, podcast episode number 63 for March 17th, 2021. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky, and I'll begin a new series, for those who are just getting into astronomy or those who want an overview of astronomy. And each week I'll be discussing a basic concept of astronomy, amateur astronomy in particular, which it's important to know as you continue in your hobby of astronomy. All that and more. Thank you for listening. See the sky this week. I'll see you next week.